Hello, Civil and Environmental Engineering 214 Geomatics at Brigham Young University. Dr. Ames here, presenting to you a little discussion about our final class project, solving spatial problems with geoprocessing, bringing it all together for a final project. This is a lab assignment number 12. Each of you will be responsible for doing individually. And so please pay attention closely to this overview, review of geoprocessing and this discussion about your final project requirements. First of all, quick review. Remember the Walmart site selection problem you should have all completed by now, and we'll be submitting online as an individual map output that you will have developed in ArcGIS Pro. Remember, we had to determine the criteria, determine what data will be needed, what tools and analyses will be used, and how will they be put in order, and then develop a workflow around that set of data and tools. Remember that we were trying to determine the conditions, not near an existing Walmart, near high-density family residences within 2 miles of a highway in Utah County, that we needed to grab some data, such as existing Walmart locations that we digitized out of Google Maps, that we needed to download Utah County and find some census blocks, some major roads, and that the main tools are select, intersect, buffer, and erase used for this project, and that we had to develop a workflow to solve this problem. We looked for Walmarts that were, obviously we want to make sure it's not placed any closer than 2 miles to an existing Walmart, but we wanted it near an existing road. We want to make sure there's a good density of population nearby and plenty of space. We found some data sets to use for different locations, and then we grabbed some tools to use, and we were able to analyze this problem and come up with a really cool, through a series of map analyses like these, come up with a great output map. I hope you've all been able to generate something like this and turn it in. So I hope that you can all answer this question. You know how to create a GIS problem workflow. By workflow, it's that whole process we go through of determining what are the constraints, what are the data sets that are needed, what are the tools that are needed, and then sort of put them in order so that we know when to clip, buffer, merge, intersect to spit out something at the end. Your final lab assignment for this course is lab number 12. And this is an individual project that you will each be doing that is not entirely unlike the Walmart site selection project. I would like you each, from the next slide, to choose one of the following projects. And you will also each choose a county in Utah. I would like you to each enter your name, your selected project, and your selected county into our Google class document. Find at least 3 appropriate data sets for your project. Determine the needed spatial analyses to solve your problem. Then build a map that shows your final project and includes a brief 2 to 3 page report that summarizes the data you used, the analyses you did, and I'll need you to explain your final map. Your map should include all required cartographic elements. You'll submit your report online by the deadline. At the end of this presentation, I will give you a brief rubric that will show you how this Lab 12 will be graded. Important for winter term 2020, since we're in Corona lockdown, I would like you to make sure you pay attention to the fact that the point distribution for the semester has changed. This used to be a 100-point project that was done as a team that had stricter requirements and was graded a lot more strictly. I have loosened the requirements for this so that you can each do it individually, and I've also lowered the points for this particular assignment to be 30 points, just like the rest of the other 11 labs. So pay attention to that as you look at the point distribution. That is all done to benefit you by not putting too much weight on this assignment, since you will have to do it individually instead of with a team. These are your options. I would like you to determine a good location for a solar panel farm. And by that I mean a location where you could put out several acres of solar panels to collect electricity, generate power for the community. Determine a good location for a landfill. You know what that is. Determine a good location for an airport. You transportation engineers, you might find that one to be interesting. A landfill, that's something for the geotechnicals and the environmental engineers. How about a good location for an LDS temple? You structural engineers may one day have to work on something like that. Determine a good location for an irrigation reservoir if you're interested in water resources engineering. That would be a good one for you to think about. So regardless of the option you choose out of this list of 5, I need you to assess or ascertain what are the criteria that need to be met, what data are required to solve. I'm saying air quotes solve because there's only so much you can do in a couple of weeks in a 200 level engineering class. We'll do our best to solve this problem. And then what tools and or analyses are needed and in what order. In other words, the same exact process we went through with Walmart, I want you to go through for this particular final project, Lab 12. So let's look at each of them briefly, and if we were in class together, I would ask you to brainstorm with me, what are some of the criteria for a solar panel farm? It's an interesting video here we could watch. It talks about a solar panel farm. Just pay attention a little bit to this.
Some of my fondest childhood memories come from the summers I spent on my grandparents' farm in Kansas. They put all their heart.
Okay. Here we go. So this is a solar.
Beautiful morning.
Yeah. Look at this. Wow. Look how big it is. So some of you that are interested in environmental engineering or clean energy, you might want to work on this problem. There are plenty of similar videos like this that you can look at to learn a little bit more about.
We're not in the desert in California right now.
Solar energy and solar farms and what is involved in site selection of one of these things. I found that video to be quite interesting. You can find these links all in the PowerPoint that is uploaded on Learning Suite. Turns out that some of the criteria might be access to a big area of land, proximity to the city that you're going to be supplying power to, proximity to existing power lines. How about proximity to roads or road networks, major highways, so you can easily get the material in here to build this thing. And one that you may not think about is water. It turns out that these things, especially, they're often built in deserts, and so they get dusty and a little dirty, and so a good supply of water, which means maybe having access to water rights you can buy up in a reservoir or a nearby river or stream would be helpful to be able to clean these panels much better than using culinary or city water. What are the data that would be needed? So if those are the criteria, then you're going to need terrain. We're looking probably for flat areas. You're going to need roads, cities, you're going to need rivers. For the terrain thing, we haven't done any raster analysis in this class, so don't worry about downloading digital elevation model data. But what you might do is just explore online areas that appear flat and find those areas that are flatter in the county that you choose. And then you could draw a polygon around the flatter areas and have that be an area that you know is fairly flat. Unfortunately, since we're working in Utah, it's quite easy to find flat areas of land. What are the tools that you'll be using to solve this problem? I can imagine buffering and clipping, intersecting and erasing, just like with the Walmart site selection problem. What is the workflow? That's for you to figure out, but I can imagine that you will have some input data sets, that you will buffer them, you will maybe do some selection on some roads and maybe buffer those and intersect them with some areas. So ponder that and think about what kind of analysis you will want to do to select or to find the optimal area for this solar panel farm in your selected county. How about a landfill? Let's think about landfills for a minute and all of the crud that appears underneath the ground in a landfill. I love this picture. It's actually pretty disgusting. If we were in class right now, I would give a little funny story about when I lived up in Idaho and I was working. My building was right next to a lovely park that was just like this one right here. It's called Freeman Park by the Snake River in Idaho Falls. I told my dad that's where my building was that my classes were taught in. He said, "What? Oh, well, I know where that is. That's where the landfill used to be. That's where I used to go kiss your mom when we were in high school." So apparently the Idaho Falls high school kids back in the 50s and 60s would go down along the river, and there was a landfill here, and so nobody went there, and they could go smooch and privacy. Well, now it's a beautiful park with all the landfill waste underneath the ground. So think about the kinds of restrictions and constraints you would want for this type of a project. Do we want access to roads? We probably want to be further away from the cities, further away from the population areas because of odor and so forth. We do need available cheap land. We do need access to it. Do we need water? Probably not. Do we need power? Probably not. So it's a little bit different set of criteria for a landfill. And you might also look at things like geological formation and so forth. You don't want to be sitting right over an active use aquifer. What are the criteria? What are the data? What are the tools? What is the workflow? This is the discussion we could have. If we were talking about this together one-on-one, I would be asking you these questions and having you brainstorm with me. Maybe grab a notepad and write some of these things down. Airports. Airports are kind of fun to think about what kind of criteria go into them. Airports are always built outside of cities, and then later the cities grow up and get closer and closer and encroach upon the airport. But that being said, it is still important to find places that have large pieces of land that are not near water, probably, that are not near major cities, that you can fly into and out of close enough. That's kind of one of those close enough to the city, but not too close to the city. Close to highways, access to lots of power, and city populations. So your county may only have a couple of cities in it, or a few. You probably want it closer to the ones with higher population within a buffer distance out of there. So think about what are the criteria, the data, the tools, and the workflow. You see the pattern here? Hopefully it's becoming a little more clear how you solve these problems. And then finally, the reservoir. This one's near and dear to my heart because I am a water resources engineer by training and in the research that I do. And this one I find quite interesting because you can look for areas of land that are actually a little more mountainous, that are further away from the cities. We don't want to be near population centers. We want to be in areas that have good terrain for enclosing a reservoir. We want to be in areas that have good access to existing power lines, and you can download power line data sets from GIS websites such as the Utah AGRC. Do we need access to roads? Probably don't need to be too close to a highway or a freeway or major roads. Minor roads would be fine to get out there and construct this thing. We do need to be on a river. So that'll be one of the critical criteria for this problem. So if you choose to work on this reservoir site selection problem, answer the same set of questions. And, oh, excuse me, I said finally, this is actually finally, it's the temple. The temple is a great project. We've got multiple temples throughout the state of Utah and the world. A lot of them are shut down right now under coronavirus restrictions. But let's imagine that we're going to build a new temple in the county that you choose. Is there already a county there? Do you want to be further away from, a temple there? Do you want to be further away from that temple? Do you want to be near population centers? Do you want to know that there's an adequate number of members of the LDS church? So you could look at stake centers, much like we did Walmarts in the Walmart problem. You probably do need to be near roads for access, etc. So if you choose this site selection for a temple, think through the criteria that make the most sense. So just reviewing the final project Lab 12 engineering project site selection requirements, you're going to choose one of the projects, the temple, the reservoir, the airport, the landfill. You're going to choose a county in Utah. You're going to choose 3 data sets to help you solve this problem, some spatial analyses to help you with this problem. You will develop a final map of your final project and you'll include it with a brief 2 to 3 page report. You'll analyze the data to help make the map. In your project report, you'll summarize what data you used, what analyses you did, and you'll explain your final map. It should include all the required cartographic elements and submit it online on Learning Suite by the deadline. Here are the project options. Seems like there was another one: landfill, airport, temple. Oh, the solar energy farm. The solar panel farm should also be up here. And then the grading rubric, 15 points for the written report and 15 points for the map. The written stuff should introduce the problem, describe the data used, describe the tools used, describe your final selected locations. And then your final map needs to have all required map elements, at least one inset map, zoom to the selected site, point marker indicating the selected site, other layers showing your intermediate results, and potential suitable zones, and then a nice looking layout. I know that's subjective, but make it look nice. Get started. There's a place on our Google document where I'd like you to go and enter in your name, your selected county, and your selected project area. Best of luck, everybody. And yeah, let's get this thing done. It's going to be awesome.